Today we're going to continue practicing looking at linear and nonlinear functions. Your objective today is to be able to identify and represent patterns that describe nonlinear functions. So before we continue, let's talk about linear versus nonlinear. Though we really hadn't spent a lot of time on nonlinear, there are some key things you should already recognize. The first being the word line is in both. What is a line? Something that's straight and that continues to go on forever and always. So linear is a straight line that continues. Nonlinear would then be the opposite. So let's give some definitions and examples. A linear function is a function whose graph is a non-vertical line or part of a non-vertical line. For example, these three. You've seen them before. Here, it's a positive line, has a constant change going from left to right. Here, there are some gaps, but still, for the most part, a straight line that is negative going down. And here, there's constant of no change, flat line that continues to go on forever and always. So again, linear means straight. The opposite of linear then would be nonlinear functions. A nonlinear function is a function whose graph is not a line or part of a line. Let's look at three different examples. One, here you have a line that curves, also called a parabola, which you'll look at later on. Here's another example where you have some type of pattern going, not constant, therefore not linear. And the last example, kind of like the one up at the top with the gaps, but again, not straight, therefore non-linear. Oftentimes, you should be able to look at a graph to know if it's constant, linear, or not constant, non-linear. So let's look at an example. Here, the area A in square inches of a pizza is a function of its radius r, and it wants us to graph this table and say whether or not it's linear or nonlinear. Take a moment to graph this data. All right, your graph for this table here about the radius and the area of the pizza should look like this. Now, first, in your table, the r should not confuse you. It is your x value, and the a, the area, is your y value. The x-axis always is your independent variable, and the y-axis is your dependent variable. Once you take a look and graph your coordinates, keep in mind x and y values are coordinates, you will get a line that is curved. It is non-linear. Another thing you should have been able to recognize is that there is no constant change. In the x values, there is a constant change increasing by 2. However, if you look at the y values, each change is different. It's not constant. Not constant often equates to non-linear. Let's take a look at another example. Here, the cost C in dollars of the sauce for pizza is a function of the weight W in ounces. Graph the function and determine if it's linear or nonlinear. I'll give you a moment to do just that. Your graph should have looked like this. The weight is your x value. The cost depends on the weight. It is your y value. Again, these are coordinates to 0.80 coordinates. And once you graph them, you will get a straight line. Again, I like to look at the change and see if it's constant. Here, the x values is increasing by 2, so it's constant. But also, the y values is increasing at the same rate of 0.80 each time. If there's constant change in both your x and y, it is linear. So we should be able to determine if the sauce is 12 ounces, the cost would be $4.80 because we know the pattern exists already. Let's look at another example where we're going to increase our rigor. we want to look at this and create an equation. The table shows the total number of blocks in each figure below as a function of the number of blocks on one edge. So here's one block. How many edges? 2 blocks. How many edges? 3, 4, and 5, which we don't know. However, we were given the total numbers of blocks for 1, 2, and 3. Take a moment, graph the data, identify the numbers for 4 and 5, and try to come up with an equation that represents this data. All right, so I don't know if you can see my dots, but I've already attempted to graph the data, but I have not come up with an equation. Now, I just want to look at the information we got from the table and just try to come up with some ways we can create this dang on equation. Do you happen to see any patterns? So, I know for my equations, I always use the variables x and y. The y depends on something that happens with the x, so that just starts my equation. But what do I have, or what do I notice that's taking place? So I'm just going to start picking numbers to come up with my equation. So if 1 is the x value and I plug in, let's see, 1 times 2 gives me 2. But I want 1, so that doesn't work. Let's try 1 plus 1. 1 plus 1 gives me 2. Oh, that doesn't work. Don't want that one. So I need to think more abstract to get this answer. If I notice, it's curving some, so it's probably not linear. And how can I get from 3 to 27, 2 to 8, and 1 to 1? Well, I know that x is probably an exponent. So I'm going to try squared. Well, 1 squared, oh, that equals 1, so that works. What about 2 squared? That equals 4, but I want 8, so that doesn't work. Well, let's try another one. And instead of squaring it, let's try to raise it to the 3rd power. 1 to the 3rd power, oh, that gives me 1, that works. 2 raised to the 3rd power also gives me 8. Oh, we're on to something now. What about 3 raised to the 3rd power? 3 times 3 times 3 is 27. So therefore, I know that is my equation, and I can use that equation to figure out the values for 4 and 5. So what are those values? If I was to plug in 4 to the 3rd power, what would I get? You should get 64. What about 5 to the 3rd power? You should get 125. And those are coordinates. So let me try to graph those real quick. I don't have them on here, but I'm going by 10. So 50, 60, 4, 64. So it'll be up here. So my line will come up and curve, not linear. So, writing a rule to describe a nonlinear function, let's go through some steps. Here I have these ordered pairs there, and I want to come up with a rule or an equation that represents this data. The first thing I'm going to tell you, step 1, make a table to organize your x and y values. You see, I created a table, and I plugged in the data given, the coordinates, into that table. The second thing is I am trying to find a rule that will give me these values. I like to look for a pattern. Well, it's an increase of 1 every time, pretty constant. But what's happening here? Oh, well, I see plus 2 here, plus 4, plus 8, plus 16. What is taking place there? I'll give you a moment to try to figure out the equation for this data. All right, so we already came up with the change in x and the change in y. We know our equation should start with the y equals. We know it should have x somewhere, but I just can't figure out a pattern. I mean, I see something here, but I'm not sure how to show that. What I do notice that, though, every time it's increasing, it's doubling. So I automatically assume, again, an exponent. And it's doubling, so I think it's y equals 2 to the x power. So let's see if that's true. Starting with the first, oops, sorry. Let's clear that up. Starting with the first coordinate, 2 to the 1 power, because I'm plugging in the x values, is 2. That works. 2 to the second power, 4. That works. 2 to the third, 8. That works. What about 2 to the fourth? Does that work? Oh, 2 to the fourth is 16. 2 to the fifth is also 32. So therefore, my equation y equals 2 raised to the x power is correct. What about this one? What is a rule or equation for the function that represents this ordered pair? Take a moment and try to figure it out. All right, so I've already made my table because that's the step 1. The second step is to look for a pattern. I really don't see a pattern. I mean, it's changed here. It changed by 3, then by 5, then by 7, then by what, 9? So I see that it's increasing. It is a constant, so I could assume the next one is increasing by 11. So I see a pattern. I automatically assume an exponent because I can see 2 to the second power is 4, 3 to the second power is 9, 4 to the second power is 16, 5 to the second power is 25. So the equation, therefore, is y equals x squared. And so I could pick a point that isn't on the table. For example, if x is 10, what is y? And I would just plug in 10 and square it, so 100. What I like about equations is you can use the equation to figure out values that aren't on the table. Here's another example. What is a rule for this ordered pair? Take a moment, create your table, identify the rule. All right, so you can see I've made my table. I'm trying to find the difference. Here's plus 4, plus 4, plus 4. So it's always an increase in 4. But if I try to figure out the next value for when x is 6, and I add 4, I get 22. And that doesn't, or 23, and that doesn't make sense. So you should have gotten for this one, oops, y equals 4x minus 1. There are some more complex ones, less complex. The key is trying to figure out the pattern and where it crosses the y-intercept. Take a look at this last one and see if you can identify the equation, and will the area ever get to 0? I'll give you a moment.